Setting up a relational database management system. Now that you have grasped the basics, it is time to get hands-on with SQL on your own computer. Open your SQL environment and follow along with the examples in this course. Feel free to pause, test queries, and explore the results at your own pace. Before you can run SQL commands, you need a relational database management system, RDBMS, installed on your computer. This software enables you to create, manage, and query databases. If you have not set up an RDBMS yet or need guidance, visit my blog at https://savecomputer.org and download my ebook on database installation. You find it under the feedback and inquiries section. The direct link is https://savecomputer.org/my-book-on-database-installation. For this course, I will be using Postgres, a powerful and popular RDBMS, but you are free to choose any system that suits you, such as MySQL, SQLite, or Microsoft SQL Server. Keep in mind that SQL syntax can vary slightly between RDBMSs, so double-check the documentation for your chosen system if a query does not work as expected. I strongly encourage experimenting with multiple RDBMSs to broaden your skills. Each system has unique features, strengths, and quirks, and familiarity with several will prepare you for diverse projects or job requirements. Do not be afraid to dive in and explore. Learning by doing is the key to mastering databases. Creating your first database. With your relational database management system, RDBMS, installed, it is time to create your first database. This is where you will store and organize your data. In Postgres, we use the following command to create a database. Create database persons semicolon. This command instructs Postgres to create a new database named persons. Be sure to end the command with a semicolon, as this is required in Postgres and most RDBMSs. When the command executes successfully, you will see Create Database in capital letters on your screen, confirming the database was created. Try running the Create Database command now, and verify it worked by listing your databases with \l in Postgres. If you are using MariaDB, you can use Show Databases, with a semicolon at the end, to list your databases. Once the database is created, you need to connect to it before you can start building tables or running queries. In Postgres, use this command to switch to the persons database. \c persons. The \c command, short for connect, tells Postgres to switch your session to the persons database. Note, this is specific to the Postgres command line tool, PSQL. If you are using a different RDBMS, the command to connect to a database may vary. For example, use persons, followed by a semicolon for MySQL and MariaDB. Always check your RDBMS's documentation for the correct syntax, as these differences are common across systems. Now that you are connected to the persons database, you are ready to create tables and explore SQL further. If you get an error like, database already exists, try a different name or check for typos in your command. In Postgres, database names are case sensitive in some contexts, persons with a capital P versus persons with all lowercase letters. Be sure to use all lowercase letters. Now that you have created the persons database, it is time to add a table to store data. Tables are like spreadsheets, organizing your data into rows and columns. In Postgres, we use the Create Table command to define a table's structure. Here is an example that creates a table called Names. Create table names. ID integer. Name variable character 50. City variable character 50. This command creates a table named Names with 3 columns. ID, an integer to uniquely identify each person. Name, a variable length 50 text field that can store up to 50 characters for a person's name. City, another variable length 50 text field for the person's city. The ID column will act as a key to connect this table to another table, like ages table, in the next section, allowing us to link related data, like a person's name and age, using SQL queries. Next, let us add some data to the names table using the insert into command. Insert into names, ID, name, city. Values. 1. Alice, New York. 2. Bob, Los Angeles. 3. Carol, Chicago. This command inserts 3 rows into the names table. The ID, name, and city part specifies the columns we are filling, followed by the values clause listing the data for each row. Including the column names is optional but recommended. It makes the query easier to read and ensures the data is inserted in the correct order, especially if the table structure changes later. This syntax works in most other RDBMSs, though some may support additional shorthand formats. To confirm the data was inserted, run. Select asterisk from names semicolon. This will display all rows in the names table. In the next section, we will create an ages table and insert data into it. Creating and populating the ages table. This process is nearly identical to the previous example. All SQL commands used here were explained in an earlier video. Let us start with creating the table ages. Create table ages. ID integer. Age integer. Now we can insert data into the table. Insert into ages, ID, age. Values. 1, 25. 2, 30. 4, 40. The ages table consists of 2 columns, ID and age. When inserting data, note that ID 3 is intentionally omitted. This is deliberate and will be explained in a later video. Whitespaces. We created the names table and arranged all fields nicely in a row format. You can also do this in a single command line, and even use whitespaces. This is also true for the insert into command. Create table names, parenthesis. On a new line, ID integer. Another new line, name variable character 50. And another line, city variable character 50. This is only for readability, and to keep an eye on the structure. At the end of the first line there is an opening parenthesis, and on the last line we close it. Then we type a semicolon to indicate the end of our statement. But, you can also type it as one long single line, and even add white spaces. Create table names, parenthesis spaces ID integer, spaces name variable character 50, spaces city variable character 50. Parenthesis. As you can see, there is white space before ID int. This white space is ignored by SQL. You can also write the insert into statement on one line, as you can see in the video. But, if you use white spaces inside text values, you will run into problems. Do not use quote, spaces, Carol, spaces, quote. That is not equal to quote, Carol, quote. In SQL, extra spaces in text values can make a significant difference. For example, Carol and Carol, with leading spaces, are treated as different values. This is because SQL compares strings exactly as they are stored, including any spaces before or after the text. This can lead to unexpected results when filtering or joining tables. If a column contains values with unintended spaces, a query like where name equals Carol, without spaces, might not return a row if the actual stored value is Carol with spaces before or after. To avoid issues, you can use the trim function to remove extra spaces. Select name, from names, where trim, name, equals Carol. This ensures that leading and trailing spaces are ignored when comparing values. What happens here? We select the name field from the names table. Next we remove spaces from the beginning and the end of the name. We compare the outcome to Carol, without spaces. This works, but I prefer to store the right values from the beginning. Always pay attention when inserting data into a table. A visual representation of the steps we have taken so far. 1. Create database persons. 2. \c persons, connect to the database. 3. Create table names, create the first table, names. 4. Create table ages, create the second table, ages. 5. Insert into names, insert data into the names table. 6. Insert into ages, insert data into the ages table. This sequence of commands sets up the basic structure we will use later in this course. The importance of semicolons in SQL. A common pitfall for beginners and seasoned developers alike when writing SQL, is forgetting to end statements with a semicolon. Why semicolons matter? In SQL, the semicolon serves as a statement terminator, signaling to the database engine that a command is complete. Without it, the engine may not execute the command or may wait indefinitely for additional input, leading to confusion or errors. For example, consider the SQL command. Create database test. If you type this and press enter, nothing happens. Why? The SQL engine is waiting for a semicolon to confirm the command's end. The correct version is create database test semicolon. Adding the semicolon triggers immediate execution, creating the database as intended. The risks of omitting semicolons. Always include a semicolon at the end of every SQL statement to ensure clarity and prevent execution errors. While some database management systems, like MySQL Workbench or SQL Server Management Studio, may forgive a missing semicolon for single queries in their graphical interfaces, this leniency can create bad habits. Here is why. In SQL scripts or command line interfaces, semicolons are often mandatory. A missing semicolon can cause the script to fail or produce unexpected results, especially when running multiple statements. Different database management systems have varying rules. For instance, MySQL is lenient with single statements, but Oracle and Postgres typically require semicolons. Relying on lenient behavior can lead to errors when switching between systems. In multi-statement scripts, omitting semicolons can confuse the engine, causing it to misinterpret where one command ends and another begins. For example, insert into users, ID, name, values, 1, Alice, no ending semicolon. Select asterisk from users, no ending semicolon. Without semicolons, this might fail or produce errors. With them, it runs smoothly. Real-world challenges. It is easy to overlook the semicolon, especially when you are deep in thought, typing quickly, or switching between tools. Even experienced developers occasionally hit enter prematurely, only to face an error or a frozen prompt. This is particularly common when using graphical tools like MySQL Workbench or dbeaver. These often execute single queries without requiring a semicolon, which can lull you into forgetting it in other contexts. Working in command line interfaces, CLI tools are stricter, and a missing semicolon can halt execution, forcing you to debug. In automation or batch processing, scripts with missing semicolons can fail silently or cause cascading errors, wasting time and effort. Tips to build the semicolon habit. To avoid these pitfalls, make semicolons a non-negotiable part of your SQL workflow. Always end every SQL statement with a semicolon, even in forgiving environments. This builds muscle memory. Tools like Visual Studio Code with SQL extensions can highlight missing semicolons before execution. When writing scripts, test them in the target environment to catch semicolon-related errors early. Familiarize yourself with the semicolon requirements of your database to anticipate quirks. If a query fails, double-check for a missing semicolon before diving into complex debugging. If you are new to SQL, do not worry, forgetting semicolons is a rite of passage. Every developer has faced the "why is this not working" moment only to spot the missing semicolon. Treat these moments as learning opportunities, and soon, Adding semicolons will feel as natural as typing a period at the end of a sentence. Semicolons may seem like a small detail, but they are critical for reliable SQL execution. By making it a habit to include a semicolon at the end of every statement, you save time, reduce errors, and write more portable code. Your future self, and anyone reviewing your scripts, will thank you for it. Whitespace issues. Let us go back to whitespace in SQL queries. SQL is whitespace insensitive, meaning spaces, tabs, and line breaks are ignored by the database engine. This gives you flexibility in formatting your queries to improve readability. A well-formatted SQL command makes the structure clear, helps identify syntax errors more easily, improves maintainability, especially when working in teams or with complex queries. For example, you can create queries that are hard to read, such as writing them on a single line, resulting in long, unwieldy code that requires scrolling left and right. Properly formatting the code, however, makes it much clearer and easier to understand. Let us take a look at an example. Select name, age, enter. From names, enter. Join ages on names.id equals ages.id, enter. Where age greater than 30, enter. Order by age descending, enter. This makes it easier to understand the logic at a glance. Just a little more on whitespaces. If you import data from an external source, such as a CSV file, extra spaces might unintentionally be included. When working with large datasets from another party, you can not always easily see what you are getting. Leading spaces are difficult to spot, but trailing spaces are almost invisible. Yes, in a well-structured CSV file, you might notice slight gaps in alignment, but only if the issue is consistent across many rows. If spaces appear randomly in the middle of a dataset, there is no visual indication, you would not even know they are there until they start causing problems. This can lead to unexpected issues, like failed joins, incorrect filtering, or duplicate values that look identical but are not. To avoid this, it is a good habit to clean your data before processing. You can use trim in SQL to remove unwanted spaces, as we will see in the next slide. Trim. The trim function in SQL is a powerful tool for cleaning up string data by removing unwanted characters, most commonly leading and trailing spaces, from a column's values. It ensures data consistency, which is critical when dealing with user inputs, imported data sets, or strings that may contain extra whitespace due to manual entry or system formatting. Trim is particularly useful in databases where whitespace can cause issues, such as incorrect comparisons or display problems in applications. By default, trim removes both leading, spaces before the text, and trailing, spaces after the text, but you can also specify other characters to remove or target only one side of the string using its variants, L-trim, left-trim, and R-trim, right-trim. For example, trim can be customized to strip specific characters like tabs or punctuation, though spaces are the most common use case. Here is how it works in practice. Update name set name equals trim, name. This command updates every row in the names table. It applies the trim function to the name column, removing leading and trailing spaces from each value. For example, a value like space John space becomes John without spaces around it. This is especially useful for cleaning up user input, like form submissions, or imported data, where extra spaces might have been introduced inadvertently. Note that trim does not affect spaces between words, only those at the start or end of the string. Before running the update, it is a good practice to test and preview the changes to ensure you are only removing unwanted spaces. You can do this with a select query. Select name, trim, name, from names where name not equal to trim, name. This query identifies rows where the name column contains leading or trailing spaces. It displays two columns, the original name, with whitespace, and the trimmed name, without whitespace, for all rows where the name with spaces differs from its trimmed version. For instance, if the database contains a name with spaces in front or after it, the query will show the name with and without spaces. If no rows are returned, it means no names have extra spaces, and the update may not be necessary. Trim is case sensitive and only removes exact matches of the specified characters, spaces by default. If you need to remove only leading or trailing spaces, use ltrim, name, or rtrim, name, respectively. Be cautious with update statements, as they modify data permanently. Always back up your database or test on a copy first. Trim is supported in most SQL databases, but syntax for custom character removal may vary slightly. We reached the end of this video on preparing our databases. In the next video, we will explore the select statement, the next step in working with SQL. I look forward to seeing you there.